Welcome to Psych 319, Chapter 14, Part 2. Continuing with heuristics, let's talk about hindsight bias. Hindsight bias is when we change our interpretation of past events to improve how we feel about ourselves in the present. Perfect example of this, Maurice Bickham was sentenced to life without parole for a crime he didn't commit. When he left prison, he was interviewed, and he said the following: "I don't have 1 minute's regret. It was a glorious experience." It was a very good chance that Maurice Bickham was sort of fabricating his experience to make himself feel better about having lived many, many years, 30 years in prison. 30 years in prison for a crime he didn't commit. So perhaps he needed to tell himself that to keep himself from major depression. Another one is confirmation bias. We've talked about this a little bit in the past, accepting observations that reinforce our schemas and ignoring those that conflict. We look for we find what we're looking for. Overconfidence is the idea that confidence and accuracy are not correlated, but not perfectly. We tend to be slightly overconfident about certain skills, and that can lead us into trouble because then we make judgments based on our confidence level rather than our actual skill level. So here's a joke here: overconfidence. Before you attempt to beat the odds, be sure you could survive the odds beating you. So in talking about decision making, there are things we should do and things we actually do, and there are two models based on these two classifications. Normative models describe what we should do, how we should make decisions. These are rooted in math and probability and so on and so forth. Descriptive models describe what we're actually doing. So utility model, the utility model of decision making is a descriptive model. We've seen that decision making is subjective to cognitive biases, and utility models of decision making. Sorry, I said it was descriptive. It's not. It's normative. Utility models is an ideal model that describes the probability of an outcome multiplied by the value. So when you want something in life, there's a value to that, and there is also probability that you will obtain that. And a utility is multiplying the probability times the value of whatever it is you're trying to obtain. Now, there's a perceptual side to utility models because they also can be used to describe the value to you as a decision maker, which makes it, in a sense, descriptive, but really the utility model is meant to be telling us what we should do, but rather than what we actually do. So I'm going to skip over this real quickly, but it's an example that's demonstrated in detail in the slides. I don't have time to go into it here, but it talks about how probability and value can be multiplied together to give you utility. And based on this idea of how we respond to things, we have different types of decision makers. If I offered you the chance to make $100 now or the possibility of $200 later, what would you take? In these types of decisions, you're offered a sure bet versus a gamble. And the value of the gamble or the sure bet or the probability of the gamble can be altered to determine what type of decision maker you are. And I'm going to go through these quickly, but there are four types. There's a risk-averse person, a person who doesn't seek out a gamble, who would rather keep money that's guaranteed. And then there's people who are loss-averse, who don't want to lose money. So the probability of gaining money is different from the probability of losing money sometimes. I'm going to skip the endowment effect. It's not important. Please ignore that for now. Sorry, there are complements to these two. Yes, there's also risk-averse, but there's risk-seeking, and, well, there's loss-averse. There's technically a loss-seeking, but nobody's really a loss-seeking personality, so it's usually one of these three. Um, Another interesting thing about utility is that utility is not the same for losses and gains. We tend to feel loss more. Loss hurts more. They say loss looms larger. So if I gave you $100, you might feel a certain amount of joy in that. But if I took away $100, you would feel worse for having lost the $100 than having gained $100. Related to this is multiple attribute utility theory. So it's utility theory, but it comes into play when there's more than one decision. So remember how we were talking about probabilities. So for every decision you make, there's a probability and a value. But when there's when there's multiple factors in that decision, there's multiple probabilities and multiple values. For example, buying a car, there's multiple things that go into it, and each one of those has a probability to value, which makes it very complex. So the Mott theory breaks down the utility for each factor and tells us what we should do. I put a side note here that utility values can be applied to anything, whether it's concrete, like commercial goods, or abstract things like love. There's a probability you'll find love, and there's a value that you personally assign to love in relationships. Everything can be boiled down to economics, whether you value that as sad or not. There's a certain truth to that. So each probability here has each factor in your decision has a decision weight, and some are deal makers and some are deal breakers. What we tend to do is we use the elimination of aspects. We tend to use the most important criteria when we evaluate decision. So if you don't have a lot of money, then price might be the most important thing when deciding how to buy a car. If you have a lot of money and you want style to show off what, you're flaunting your money and you want to make a good impression, then style might outweigh value or gas mileage. So sometimes one aspect receives an undue decision weight, more decision weight than it probably should, and we tend to use that when we make complicated decisions. So that's what we should do. Descriptive models of decision making are different. Utility models are idealistic, but we don't tend to use those. We're bad at extreme complex situations, under the pressure of time, when the problem is difficult to define, when we're emotionally involved. Another thing to say about utility theory is that we're really bad when probabilities are either very, very high or very, very low. So for example, when probabilities are very, very low, we sort of overestimate that probability. That's why people play the lottery. They believe, even though there's a very, 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 very small chance, they still believe there's a chance they can win. Honestly, you shouldn't play because there's a larger guarantee that you're just throwing money away. So when you play the lotto, it's basically they're taking advantage of your overestimation of low probabilities. Similarly with high probabilities, if I tell you that there's a 99% chance that you won't go through a hurricane next year, you might say, well, there's a chance that I could go through one, and that might lead you to buy insurance. So not that you shouldn't buy insurance, but insurance companies bank on the fact that there's a larger chance something won't happen. But we tend to also underestimate extremely high probabilities, just like we overestimate extremely small ones. Anyway, continuing. So what do we tend to do? One idea is that we use image theory. We pre-visualize a problem and compare the possible options available to us to that visualization. If there appears to be a fit, either to our schema or our goal state or the initial state and the path to a solution, then we'll go with that decision. You don't have to really know all of these here, but the general idea is that we're comparing what we've preconceived in our mind to what we think the possible solution to a decision is, and then we just go with it if it matches. Sometimes, though, this was really can be a problem because oftentimes the decision is not the direct path you think it's going to be. Just as I can't show you these now because I usually do these with the chalkboard, but the subway is a good example. Sometimes you have to go north to go south. Sometimes you have to go on a train line that takes you well into Manhattan before going from Queens to Brooklyn. While you think the direct path might be the best solution, maybe the fastest solution is actually taking a very unusual train route to get you to where you need to go. And that's where using image theory might fail you. Recognition prime decision making is similar. Um, Sometimes we make decisions without evaluating things. This you might consider this a knee-jerk reflex, when you just go with your gut. And going with your gut, oddly enough, sometimes is actually accurate. Blink by Malcolm Gladwell is an entire a book on the idea that people sometimes make their best decisions in a moment's notice. And if you think about how the brain works, it's really just how efficient heuristics are. We can use heuristics very effectively because we have a whole lifetime's worth of memories that contribute to these decisions, and sometimes they can be very, very accurate. It's really an extreme example of image theory. So we're doing this coarse pattern matching. We take our memories and our schemas and our lifetime of experience, and we try and match them very, very quickly to the situation and make a gut decision, and oftentimes our brain does a good job of it. The research has shown that the best decisions, most reliable decisions, are made combining emotional and cognitive decision-making strategies. You don't want to be too cognitive because then you might be ignoring your feelings, and you don't want to be too emotional because then you might be ignoring logic and proper reasoning. So you have to sort of take both into account. This is a couple of examples of the neural side of decision-making. You can see the details in the slide, but essentially when you train a monkey up on a task and you bias this task, so the monkey is supposed to make an eye movement wherever this target goes, 80% of the time the target goes to the right, and only a few times does the target go on the left. It's rewarded for making the proper decision, and the amount of the award can also be biased. So what's interesting here is when the monkey knows it's going to get a decision because 80% of the time it's rewarded on a particular trial, the firing rates of neurons in a particular brain area associated with reward will fire much, much more. It knows it's getting a large reward. The interesting thing is this happens well before the reward is actually delivered. So it's sort of that the brain can anticipate. It can anticipate this reward based on the perceived probability and the perceived value. So not only does it fire when there's a larger probability of getting the reward, but also when the amount of juice delivered is higher. So it's a neural representation of utility, probability, and value. This is another thing, the same thing in a little more detail, but I just wanted to show you this are the spikes. This is when the stimulus turns on, and this is when reward is actually delivered. What's important to note here is that for some cells, they fire more when the probability of getting that juice is higher, and they know it's going to be a good payoff. The cells fire immediately after the stimulus is presented, not after the reward. It's as though the brain immediately knows from seeing the stimulus that this is a good decision. This is a gambling game that was played with humans, and these are MRI results. And humans were given the same amount of money for correct decisions, but they were told that the amount of time between the decision and the payoff was going to vary. So either they were going to be given the money immediately that day, after 2 weeks, or after a month. And you can see that when they thought they were going to get the money immediately, they had a larger brain response to those decisions compared to if the delay was going to happen a lot later. And when you look at different brain areas, it turns out when people choose early payoff, if they have a choice and they choose early payoff, the emotional centers of the brain become more active. If they choose a late payoff because maybe it has a higher reward, then the rational areas of the brain end up yielding a higher response. So there are two systems here, one based on a short-term goal, kind of your greedy desires, and another system that's dedicated towards rational thinking. And these are very much tied to each other. They're not mutually exclusive. But it's interesting to see them in action. You can the classic example is eating a chocolate bar, a moment on the lips, a lifetime on the hips. You get an immediate emotional payoff for eating that, but there's a larger reward associated with staying healthy. And if you were to do the chocolate experiment, you would probably find that rational areas of the brain would light up for not eating chocolate, and emotional areas would probably light up for eating chocolate in that moment. Anyway, so how can you improve your decision making? Just the mere fact that you've attended this lecture means that you're going to make better decisions in the future. That's a known fact. Another important thing to always remember is remove obstacles to difficult decision making. Define problems clearly. Be aware of your goal state, your initial state. Don't be overconfident. Recognize the cognitive biases that everyone is a victim of. Use your memory. Use memory aids like the computer. It helps you keep track of the problem. Anyway, I hope you learned something from this, and I will see you in the final chapter next week.